In this video, I'm going to look at how to find the area between a curve and the y-axis. So suppose you want to find area A on this graph. The first step will be we need to make x the subject in whatever function that you're given. So make x the subject and then find the definite integral with respect to y between the y limits that you're given. For example, from y is equals to a to y is equals to b. I'll show you this in this example. So find the area of the region bounded by the graph of the function and the lines y is equals to 1 and y is equals to 4. Now, the first thing that you need to do is to sketch this function. Now, before I sketch this function, there are a few things that I want to go through that will help us to get an idea of how to sketch this function. Now, this is what you covered previously. When you are looking at functions, consider the graph of y is equals to x squared. Now, suppose you want to get this graph from that. There are few things that you need to remember, what we covered previously. Now, the first thing is where the graph of y is equals to x squared lies above the x-axis, the graph of y is equals to 1 over x squared will also be above the x-axis. So what I mean here is where the graph of y is equals to x squared lies above the x-axis. So 2 does the graph of y is equals to 1 over x squared. The second thing is where the graph of y is equals to x squared touches the x-axis, the graph of y is equals to 1 over x squared will have a vertical asymptote. So where the graph of y is equals to x squared and another thing is as the graph of y is equals to x squared increases, the graph of y is equals to 1 over x squared decreases. So when where one increases, the other one will be decreasing, and where the other one decreases, the other one will be increasing. So as the graph of okay, so if we keep these key points in mind, then we should be able to draw the graph of y is equals to 1 over x squared from the graph of y is equals to x squared. And I'll show you how to do that here. So here I'll have the graph of, y is equals to x squared, just a sketch, touches the x-axis there, y and x. And here I'll have what I need, which is the graph of y is equals to 1 over x squared. So the vertical asymptote is where the graph of y is equals to x squared is touching the x-axis. So the y-axis will be our vertical asymptote. On the left, this function here, um, this function here is decreasing, which means this function will be increasing. It will be increasing, and then so what I mean is this function here will be increasing, and on the right, this function is increasing, which means this function will be decreasing. Y is equals to 1 and y is equals to 4. So this is the area that we are looking for. This and this one here. Let's now find the area of the shaded region. I'll start by labeling that part A as A and that part as B. Of course, you can notice that A is equals to B. These two areas are equal, so all I need to do is to find the area of A multiplied by 2, and that will give me the area of the whole region. Anyway, step 1, I need to make x the subject. We know that y is equals to 1 over x squared, which means that x will be the square root of 1 over y. What I want to start with here is I'll start with the values of x that are greater than 0. For x is greater than 0, because I want to use that to find the area of A. Now the area will be the definite integral from y is equals to 1 to 4 of square root of y, square root of 1 over y with respect to y. That will give me y to power negative a half plus 1 over negative a half plus 1, and the limits are 4 and 1. This will be 2y to power a half, and the limits are from 1 to 4. Okay, if we work this out, we'll be able to get 2 to power 4 to power a half minus 2, 1 to power a half, which will be 4 minus 2, which is just 2. So the total area or area of the shaded region will be 2 plus 2, which is 4. I'll look at the next example. Find the area of the region bounded by the graph of the function y is equals to x cubed plus 1. It's just a cubic function. Translated 1 unit up. The y-axis and the lines y is equals to 1 and y is equals to 9. So, first thing is to sketch the graph. Okay, it's a cubic function translated okay, this is not really the best one. If I have something like that, that will be better. I really don't need this part. Okay, so between y is equals to 1, so y is equals to 1, and somewhere there y is equals to 9, and this is the region that I'm interested in. Um, so the first step is make x the subject of the formula. So y is equal to x cubed plus 1, which means that x cubed will be y minus 1. X will be the cube root of y minus 1. Or we can just write this as y minus 1 to power a third. So the area will be integral, definite integral, y minus 1 to power a third dy. And we'll have to use substitution here. So just extend the page a little bit. Let u be equal to y minus 1, which means du over dy will be 1, which means that du is equals to dy. At y is equals to 1, u will be equal to 0. And at y is equals to 9, u will be equal to 8. So we'll end up with an integral with new variables from 0 to 8, u to power a third du, which will be equal to u to power a third plus 1 over a third plus 1. U to power 4 over 3 which will be just 3 over 4, 8 to power 4 over 3 minus 1. And that will give us 12. So this area is 12. Next question. Find the area of the region bounded by y is equals to 4 minus x squared, y is equals to 3, and y is equals to 4. Okay, the first thing is I need to sketch this function. So it's just a quadratic function. This is the turning point. Anyway, between y is equals to 3 and y is equals to 4, so somewhere there and somewhere there, y is equals to 4, y is equals to 3. This is the area that we want. What I'll have to do is just like in the previous question, I'll find the area of A first, and then to find the area of A plus B, I'll just double them. Double the area of A. So first step is make x the subject of the formula. So y is equal to 4 minus x squared, which means x would actually be 4 minus y to power a half, which means the area will be equal to integral from 3 to 4 of 4 minus y to power a half dy. Again, by substitution, let u be equal to 4 minus y. So du over dy will be equal to negative 1, which means du actually dy will be negative du. Okay, and then at y is equals to 3, u will be 1. At y is equals to 4, u will be 0. So we can now proceed and find the definite integral with the new variables. So the integral, so area will be the integral from 1 to 0 of u to power a half multiplied by negative du. That will be negative, I can just go ahead and integrate this. So that will be u to power 3 over 2 over 3 over 2, 0, 1, which will be equal to negative 0 minus 2 over 3, 1 to power 3 over 2, which is 2/3. So area of a shaded part, area of a shaded part, which is A plus B, area of part A and part B, will be 2 multiplied by 2 over 3, which is 4 over 3. Next question. Find the area of the region bounded by the function, the y-axis, and the given lines. So the first thing is, by inspecting this function, so if we plug in this function any value of x that is 4 or greater than 4, will end up with a, in fact, if we plug in 4, we'll end up dividing by 0. If we plug in any value of x that's greater than 4, we'll end up with a negative square root. So we are basically saying here that the domain is all values of x that are less than 4. Those are the only values of x that you can plug into this function. The vertical asymptote, so again, this is just on this function, vertical asymptote. Okay, the vertical asymptote of this function will be x is equals to 4. If we equate the denominator to 0, find that x is equals to 4. Horizontal asymptote will be y is equals to 0. I showed you previously when you're looking at functions how to find the horizontal asymptote. And then let's try and work out any y-intercept. So at x is equals to 0, y will be 1 over square root of 4, which is a half. Now, I know some of you will say plus minus a half. Well, we can have plus minus a half, otherwise we won't have a function. Okay, so it's just a half. That way you can have a function. Otherwise, if you say plus minus a half, then we won't have a function. You know the definition of the what a function is. So we'll just end up with one value of y. Anyway, now that we have all this, we can try and sketch this function. Have an idea of, we at least have an idea of how it looks like. Vertical asymptote, x is equals to 4. It exists to the left. Cuts the y-axis at a half. And horizontal axis is the x-axis is the horizontal asymptote. So the function will look something like this. Okay, something like that. Now, we are trying to find area of the region bounded by the function, and y is equals to a half. So y is equals to a half, which is here. Y is equals to a half, and the line y is equals to 2. So y is equals to 2 is somewhere there. Y is equals to 2. So this is the area that you're trying to find. Good. Let's carry on and find that area. So area will be equal to actually, before we find the area, let's make x the subject of the formula. Now we know that y is equal to 1 over negative x plus 4 to the power a half. So which means negative x plus 4 to the power a half is equals to 1 over y, which implies that negative x plus 4 will be 1 over y squared, which means that x will be equal to 4 minus 1 over y squared. So we can now move on and start integrating this guy. So required area will be the integral. The lower limit is a half, upper limit is 2. The function is y minus 1 over y squared with respect to y. So what we'll end up with is 4y minus y to power negative 2 plus 1 will be negative 1 over negative 1 to a half, which will give us 4y plus 1 over y, 2 and a half, which will give us 8 plus a half minus 2 plus 2, which will give us 8 and a half minus 4, that is 4 and a half. So the area of this curve is the shaded region is 4 and a half.